Good afternoon, everybody. I, Dr. Mukim Ahmed, here present the topic Introduction to Database Concept. So, these are the outline of my presentations. Now, I am going to introduce the Introduction to Database System. Before starting the whole introduction of the database, we should know first of all what is the database actually. The database is nothing, it is a collection of related data or the informations that is stored in such a way or organized in such a way where anyone can access that data. So the basic example of the database is the telephone directory, we can say, where subscriber names are arranged in alphabetically order. Dictionary, where the words are arranged in alphabetically orders. One more two examples are there: airline reservations records and the motor vehicle registration records. Now come to the basic concept, foundation of the data concept. So the foundation of data concept is the abstract concept or abstract view of the data. The abstract view of the data is, first of all, we should know the entity and then attribute. Entity is nothing, it is any person, place, or object or event that is stored as a record for a table row. Attribute is nothing, it is the properties or we can say the characteristics of the entity is stored as a field or the table column. Now the basic foundation of the database is the database, which is a collection of related tables, and the table is nothing, it is a collection of the related records or the collection of related entities. Record is nothing, it is a collection of fields represent as an entity, and field is the collection of the characters, that is the table columns, and the character is nothing, it is a single alphabetic, numeric or other symbols. Now what is the field actually? Field is nothing, it is a characters, group of characters, just like a Smith. Smith is nothing, it is a last name which represent as an fields. Field is an attribute of an entity, we can say. Records, bunch of field form a records. With the help of fields we can make a record. For example, we have the first name, last name, gender and weight. The collection of these first name, last name, gender and the weight will become a records. Record is an entity. Now the table, bunch of record form a tables. Okay, for example, here first name, last name, gender and age. John Smith M46 is the record, and the bunch or we can say the group of records. For example, John, Joshua, Parul. The collection of these rows will become a tables. A table is a group of related entities, we can say. This is the basic representation of the database design. Database is nothing, it is a collection of the table, we can say table 1, table 2, table 3 and table n. And the table is nothing, it is a collection of the records. Here we can represent the record 1, record 2, record 3 and up to record n. This is the collection of records, that is called the tables. And what is the records? More than one field make a record. Now this is the example of the database. We can say the bunch of the tables form our database. For example, we have the customer table, product tables and the order tables. The database can represent a single business or the entire market. And this is the another example of the database, but database are not just a bunch of the tables. We have the orders, customer or products. A database also include the relationship also. We have to maintain the relationship between the tables. Here we have the orders, we have the customer, we have the products. If there is a relationship between customer and orders and the products, so that will be the database. Now what is the difference between traditional file processing system and the database? To know the difference, first of all we should know the what is traditional file processing systems. So in the traditional file processing system, data is organized or stored and processed in independent files or data records. Sometimes the files are spreadsheets, sometimes they can even be the word or the text documents. This is the, we can say, the representation of the file processing systems, where the, we can say, the disadvantage of the file processing system is the redundancy, the duplicacy of the data. Duplicate data requires update to many files. Lack of integrations means the data is stored in the separate files. The hard to combine the data. Data independence, actually change the file format require the change the program also. Here program is dependent on the files and the files is dependent on the programs. Now this is the actual database. This is the centralized storage. We can say this is the central repository of the data that defines once and accessed by the various users. It completeness, it is stored in a single logical place. Data can be shared and related between the applications. Data transfer between application is easier and it is used to wide range of the applications. Now this is the difference between the file processing system and the database oriented systems. In the file processing system we have to create a separate files, but in database oriented approach we have to create a centralized database and we can access that centralized database anywhere. This is another examples of the database, or we can say the there is a need of the tools to access the data from the database. So that tool is nothing, it is a database management systems. It is nothing, it is a software system that define, construct and manipulate the data in the database, or in other words we can say the software that control the creation, maintenance and the use of the database. So it acts as a mediator between the database and the applications. So every request of the applications, or we can say the users, customers, will be sent directly to the database, and from the database that request is transferred to your database, where actually database is stored. If that data is accessed through the dbms, that request is respond to the applications, customers or the users. So basically it acts as an intermediate, just like in the CRM, customer relationship management system, the salesperson act as an mediators or the intermediate between the storage and the customers. So dbms act as an salesperson. So the purpose of the database systems is the data redundancy and the inconsistency. It reduces the redundancy, and after controlling the redundancy the data will be consistent. Difficulty in accessing the data in file processing system, there is a difficulty in accessing the data, but here by using the database we can avoid the difficulty. Integrity, it maintain the integrity. Atomicity problems, in file based approach there is atomicity problems. For example, if we are taking the example of the fund transferring protocols, if we are transferring the amount from account A to account B, see the basic example, if we are going to transfer the amount from account A to account B, at that time if the system fails, so there will be the both credit and both debit if we are using the database oriented approach. But in case of the file based approach there will be the problem of atomicity. Concurrent access anomalies, in the file processing system there is a anomalies of the concurrent access, means more than one user can access the data at a times, and there is a problem of backup and recovery in the data file based approach. But in case of the database oriented approach, we can take a backup and we can recover our database. Security is the one of the important problem in the file based approach, but by using the database oriented approach, we can make our database more secure. Now the main characteristics of the database approach: it provides the abstraction view of the data, means everything will be hidden. A data model is used to hide the storage details and present the user with a conceptual view of the database. Support the multiple view of the data, sharing the data and multiple user transaction processings. Now the example of the database: in case of the university database, we can divide the database into the three views: conceptual view, external view, and the physical view. Conceptual view of the university is the students, where student records are identified as a student ID with data type strings, name with data type string, login with a string, and age will be in the integers. Course is another entity where the fields are course ID string, C name, course name is string, and credits is strings. Enrolled student ID is strings, CID is strings, grade will be strings. External schema view is the course informations, CID string, enrollment integers. Physical schema is the relationship stored as a unordered files index on the first column of the students. Now the data independence. Data independence is nothing, it is the ability of the modification of the schema definition at one level will not affect to the next higher level. It is the interface between the various levels, and components should be well defined so that the changes in some parts do not seriously influence the others. The two level of the database independence are physical data independence and the logical database independence. Physical data independence is nothing, it is data independence, or we can say the modification of the data at physical level will not affect to the conceptual level or external levels. Another is the logical level, logical data independence. Logical data independence says that if we want to change at conceptual level, or we can say the logical levels, the change made at logical level will not affect to the external levels. So this is the architecture of the we can say the database. Through this architecture we can see the data independence. These are the three views of the data: view 1, view 2, view 3 is the external view, conceptual view is the middle, and this is also sometimes called a logical view, and this below the conceptual view there is a physical level, and below the physical view there is a database where actual data will be stored. So at physical level, change made at physical level will not affect to the conceptual level, and the logical level will not affect to the external level. Now the types of the dbms. There are different types of the dbms here. First one is the hierarchical database management systems, where it represent the records in the form of the tree data structures. Network database management system represent the records in the form of the graphs, that is, it support many to many relationship. Object oriented database management systems, it represent the record in the form of the class, and the most important to which we are going to present is the relational database management systems, which represent the record in the which represent the data in the form of the tables called the relations. Now is the relational database management systems. The most widely used database system is today is the RDBMS, or the relational database management systems. Its concept include the table, constant, and the operations. It is developed by the Dr. E.F. Coates, C.J. Dates in 1970s. So the table will be identified by the entity, and entity will be identified by the relations. Table row is nothing, it is a tuple, and tuple will be the instances. The column is attributes, and the linkage by the values. Now is the example of the relational database management system. We have the table 1, which have the attributes name, address and the partial number. Another table 2, which have the partial number and the assisted values. So here this the partial number is related to your table B is partial number. So we have to make the relations between the two tables. That is the partial number in the table B is the primary key and the partial number in the table A is the foreign key. So the database tables key. What are the keys? Basically the definition. The key of the relation is subset of the attributes with the following attributes: unique identification and the non-redundancies. With the help of the key we can make a unique identification in the database and it will reduce the redundancy. First one, the types of the key. In the type of the key, first one is the super key. It is the set of the attributes whose value can uniquely identify an entity in the entity sets. A super key contains one or the more attribute. For example, the combination of SSN and name is a super key of the following entity set: customer. Next is the candidate key. It is the set of one or more attributes whose value can be uniquely identified an entity in the entity sets, and any attribute is the candidate key cannot be omitted without destroying the uniqueness property of the candidate key. It is the minimal super key, we can say in other words. So SSN comma name is not a candidate key because the taking out the name till leaves the SSN, which can uniquely identify an entity. So SSN is the candidate key of the customer. In case of the drivers, example, both SSN and the license numbers are the candidate key of the driver entity sets. The primary key, this is the one of the most important things. The primary key is nothing, it is the column or the set of column that provide the uniqueness for the row. A table can have only one primary key. Existing value in the primary key columns cannot be modified. The table of the relationship containing the primary key is called the parent table, and the SSN and the license number both are the candidate key of the drivers entity set. The database designers can choose either one as the primary key. So this is the example of the primary key. In the customer table, see the customer ID, name, company, phone number and mail address. So here customer ID is the primary key that will be identified uniquely and which cannot be blank or which cannot be null. Phone number is also the uniqueness, but in case of phone number can be blank, can be null, but the customer ID will be unique and cannot be blank. So primary key is the unique identifier of the records in a table. Primary key value may be generated manually or automatically. This is another example of the primary key. If there is not a uniqueness in the tables, we can make a combination of the attributes to find the record unique. So the collection of the attributes will also be the primary key. And the foreign key, a primary key reference from another table is called a foreign key. Foreign key is nothing, it is the key through which we can reference another tables. For each foreign key value, there must be a row in a table whose primary key has the same value. The foreign key can be made up of one or the more columns of the table, but must watch the primary key in its referencing. A table can have any number of the foreign key. Foreign key will be any numbers. It will be 1, 2, 3, 4, 5. But in a table, the primary key will be only 1. This is the example of the foreign key. This is the table of directors and the movies. So director ID is the primary key in the directors and the director ID in the movie is the foreign key. Now the database language. Database language is categorized into the 5 parts. First is the DDL is nothing, it is a data definition language. DML data manipulation language. TCL transaction control language. DCL is the data control language. Thank you.